13.1, we're going to graph sine and cosine functions today. Based on what we did yesterday with the unit circle, we're going to start there. We're not going to do the whole unit circle. We're just going to do the quadrantal angles. Okay, because that's when we graph these, that's what we're going to focus on, is the quadrantal angles. So, if anybody remember what a quadrantal angle is?
Angle in the certain quadrant.
It's an angle not in a quadrant, because it's on an axis, either the x or y axis. So we're not going to worry about any of the ones actually in the quadrants. We're just going to work with the ones on the axes. So, now you'll notice when I wrote these out here, I have sine of 0 degrees, and I have 0 for radians in parentheses. So let's just start with the quadrantal angles. If I start right here, what angle is it when I start? 0. Yeah, we start at 0. And what ordered pair goes with that one? What's my x value? 1, 0. X value is 1, y value is 0. I'm going up and down 0. Okay? So when I come up to this one, and we're going to do radian measure here, what angle's up here on the positive y-axis?
In radians?
In radians.
Pi over 2.
Pi over 2, 90 degrees, or pi over 2, because we're going to graph everything in radians. Okay, so what is the x and y that goes with that point? 0, 1. Okay, if I come down here to the negative x-axis, what's the angle that goes with that one? Pi, or 180 degrees. And the ordered pair? Negative 1, 0. Down here. What's that angle? 3 pi over 2. And my ordered pair is 0, negative 1. The y is negative 1, the x is 0. And then when I come all the way around, I start over. And when I've gone around once, I get back to 2 pi. That's going to give me one cycle of my sine or cosine function. So, now, in the unit circle, r is always 1. So where do I look to find the value of my sine function?
Okay. The y.
In the y spot, right? I've got x, y, sine of theta equals y over r, but in the unit circle, r is 1, so it's going to be just the y value. So, sine of 0 is 0. Sine of 90 degrees, or pi over 2, is 1. Sine of 180 degrees, or pi, is 0. Sine of 270 degrees, or 3 pi over 2, is negative 1. And sine of 2 pi. Okay, we're going to look at the sine function, and then we'll look at the cosine function. Those 5 points are what I'm going to call your critical points in graphing these. Those are the ones that we're going to be worried about. We're just going to connect dots in between. Okay? So, if I want to graph y equals sine x on the x-axis, I'm going to worry about my angle measures. The angle measures are your input values. Those are going to be your x values. So here's what I want you to do when you graph these. You're going to start with the period. The end of the period is 2 pi, so we're going to label that. So you're going to start with the length of the period. Then you're going to cut the period in half. Well, what's halfway to 2 pi? 180, or pi. Okay, I'm going to cut that one in half again. Well, half of pi is pi over 2. So what that tells you, we're going to divide it into 1, 2, 3, 4 equal quadrants. Each quadrant is pi over 2. So I have pi over 2, plus pi over 2 is pi, plus pi over 2 is 3 pi over 2. So that's the first thing on every one of these that you're going to do is label out the 4 equal parts of your period. Then you're going to say, okay, I look at the values to go 0, 1, 0, negative 1, 0. So 1 is the highest I go. Negative 1 is the lowest I go. I'm going to plot those 5 points. I have the point 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0, and then I'm going to sketch between those points. Now these are not sharp points. It's a nice curve as we saw yesterday. And we also talked about that it continues and repeats and repeats and repeats. You're going to have arrows at the end that say this is going to continue on indefinitely. So questions about the sign of x?
No.
Okay. Now let's do the first. Yes?
What's y equals sine x?
That's what I just graphed here.
Oh,
X is the angles and y are the sine values. Okay? So on this one, we're going to graph the equation y equals cosine. Okay, it has the same period, so we're going to divide it into the same 4 equal parts. So on the x-axis, I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. My highest point is going to be 1. My lowest point is going to be negative 1. So let's look around our circle and see cosine of 0. Remember that is cosine theta is going to be my x over r, but r is 1, so it's just going to be the x value. So I've got cosine of 0 is 1. Cosine of 90, 0. Cosine of 180 or pi, negative 1. Cosine of 3 pi over 2, 0. And cosine of 2 pi is 1. And we always wind up on the same one that we started on. Okay, so let's plot those points. I have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, 2 pi, 1. Now we're going to connect the dots, but be a little bit careful with this. When you put your arrows on, remember that this is the highest point it goes. So I'm going to start by making sure it looks like it's going to go down. And when we look at just one cycle of the cosine, since we start at the high point, end at the low point, or high point, make sure that before you put the arrows on, you turn it over. Otherwise, it looks like you got a V going on if you just put your arrows headed off. So that's to remind you that that continues on. It's like a snake. It just keeps going forever and ever and ever. Okay? So there's your sine and cosine functions. Question. Okay, based on what we did yesterday, hopefully that makes some sense. Relates to the unit circle. Okay, so what we're going to be working on today is a little bit, we're going to play with it a little bit. We're going to have y equals a times the sine of bx. We're going to talk about what a and b represents, and y equals a cosine of bx. So this a, whatever number is times your sine or cosine, is going to tell you what the amplitude of your function is. The amplitude is defined as the distance from the midline of the graph to the highest point. Now today the midline of your graph is always going to just be the x-axis. That's going to change tomorrow. For today, the highest point is going to be a, the lowest point is going to be negative a, and that's going to give me the amplitude. So the distance from the x-axis up to the highest point is going to give me the amplitude of the graph. Okay, the second thing that we're going to talk about is the period of the graph. That's how far it takes. Okay, first we'll define it. Period is the distance from a starting point to where the function repeats, because it has this little chunk and then it just keeps doing it over and over and over and over. So the distance from it starts to where it repeats. We're going to find the period using this b, which is the number times the argument of the sine or the cosine function. So to find the period, we're going to say 2 pi over b. So this would be 2 pi over the absolute value of b, and the distance from here to here. That's my period. And we're going to play with a couple of them so you kind of see how these work. And of course, we're going to divide it into 4 equal parts. And if we were to sketch, say, the sine on there, it would look like this. So no matter what the period is, no matter what the amplitude, the same basic shape is going to be there. It's just going to change how stretched out it is, how high this way it is. Okay? Okay, I know I have a lot written up there, so I'll give you a minute to write, and then I'll move to the example.
So are we going to be given B and A and having to...
I'm going to give you an equation. You're going to look at the equation, and from that you're going to figure out what A is, what B is, and you're going to graph the function. Okay. Now, I want you to be a little bit careful. Remember the definitions as I have them here for your amplitude and period, because we're going to play with that tomorrow. We're going to be moving it up and down. So it's not just from the x-axis, it's from the midline of the graph. So I move that whole graph up and down. We're going to have fun with that. Okay, we got it? We're ready to move on? Okay, I got 2 examples, and then I'm going to let you go to work graphing these. Oh, we do have to take a quiz today, too. Okay. I'm going to give you 2 examples. One where we play with the amplitude, and one where we play with the period. There are going to be some on your assignment that deal with both, but if you understand each individually, you should be able to deal with that too. Okay, so the first one is the equation y equals 4 times the sine of x. Now, if you remember the equation y equals a sine dx, okay, when you look at that, what's my a equal to? 4. What's my b equal to? 1. There's nothing there. You assume it's 1, okay? So if a equals 4, that's my amplitude. So that means the highest this is going to go is 4. The lowest it's going to go is negative 4. That's my amplitude. Now, my b is 1. So my period is going to be 2 pi over 1, which is just 2 pi. So I don't change anything there. So from the y-axis out to the end here, we're going to say that's 2 pi. And I'm going to divide that into 4 equal parts. So half of 2 pi is pi. Half of pi is pi over 2. So I know each equal section will be pi over 2. So the easy way to find this one, now this one is what we've done before, but it's going to change. So the easy way to find this missing part right here is to take pi over 2 plus pi, which gives me 3 pi over 2, and I have my 4 spots on those 4 important critical points where Now the next thing I look at it and say, okay, this is a sine function, so where am I going to start? Sine of 0 is 0. So you're going to start at 0, and then sine goes up first, so you're going to go to pi over 2, and you're going to go to your high point. You're going to go to pi, come back to 0, go to 3 pi over 2, go to the low point, wind up at 2 pi back at 0, connect the dots, nice curvy lines, arrows on the end. Got it. Things I'm going to look for are those 4 labels on the x-axis, the high point and the low point label, nice curves, arrows on the ends. Last one. This time we're going to play with the period instead of the amplitude. So when I say y equals cosine 4x, think about y equals a cosine bx. So here, what's my a equal to? 1. So that's not going to change. Now here, my b is 4. So my period is 2 pi over 4. So if I simplify that, that's going to be pi over 2. So my period is going to be pi over 2. Now for today, I'm not going to worry a lot about scale. So I'm going to let you just divide that x-axis into its 4 equal parts. You can go out here to the end and say the end of my period is going to be pi over 2. I'm going to divide it in half. What's half of pi over 2? Pi over 4. What's half of pi over 4? Pi over 8. Okay, gotta add some fractions here. What's pi over 8 plus pi over 4? 3 pi over 8. Okay, another way to think about that. Here's 1 pi over 8, 2 pi over 8, which simplifies to pi over 4, 3 pi over 8, 4 pi over 8. So if you get that first quarter, each one has to be that. So you can just count, and that's another way to do it. Okay, so now I've got that part done. My amplitude goes up to 1, down to -1. Okay, the cosine of 0 is 1. So I'm going to start at the high point. I'm going to go to 0 at pi over 8. I'm going to go to -1 at pi over 4. 0 at 3 pi over 8. Back up to 1. And sketch my curve, making sure to curve down at the ends, because that shows it continues on in the same fashion. Questions? These shouldn't be too bad. Yes, there are some graphs where I could find 5 points. So y values are pretty easy. Got to kind of play with the fractions on the x values.